So this video, we're going to talk about acid-base neutralization reactions. All right, so which is a special type of chemical reaction. All right, so this process is where you have an acid reacts with a base to yield water plus an ionic compound. And this ionic compound, we call it salt. All right. So first, before we really jump into this, let's define what is an acid and define what is a base in this sense, right? And so an acid is basically a substance where a hydrogen, right, is attached to some type of anion. So I will call that anion A. Okay, so an acid is just a hydrogen attached to some type of anion. So examples of this is HCl. All right, this is an acid. HBr, this is another acid. Here's another one, HNO3. All right, the anion in this case is a polyatomic. All right, but you see that you have hydrogen attached to an anion. Okay, so this right here is your acids. Okay, now a base, okay, is when you have a metal, which I'm gonna call it M, bonded to an hydroxide ion. Okay, so any type of metal that's bonded to a hydroxide ion. So for example, sodium hydroxide, Na is your metal, OH is your hydroxide. Here, magnesium hydroxide. Okay, this is a base. Let's go with one more example. Ammonium hydroxide. All right, so here it's still the cation in this case, but still at the end of the day it's something that's attached to this OH hydroxide. Okay, so in this case, for an acid-base neutralization, you have an acid that reacts with the base, and ultimately what's going to happen is that you have the H of the acid, all right, that's going to bond with the OH of the base to make this water, right? So you have H that's going to react with OH to make H2O, okay? And then what happens to the other ones? Well, the anion and this cation is going to bond to make this ionic compound, which we simply will call a salt, okay? And so if you were to kind of look at to generalize this, right, what we will have basically this HA, so the hydrogen and its anion, right, plus we will have the metal bonded with the hydroxide, all right, and is going to form, what you're essentially going to form is that you're going to form H2O, and that comes from these two together, bonded together, okay, plus you're going to have your metal, all right, or your cation with your anion, all right, and most times this will be in an aqueous solution. This is going to be your salt. This right here is going to be your water, all right, this is your acid, and this is your base. Okay, so this is a neutralization reaction. Okay, so let's kind of look at some examples of this. Okay, like, so for example, if we were to mix, let's say, sodium hydroxide, and we're going to react it with hydrochloric acid. All right, if you notice, here is my base. All right, here is my acid. So we have an acid-base reaction. We have the OH and the H. All right, and so when they bond together, right, the OH and the H is going to make H2O. So this is my water, and that stems from these two combining together. All right, plus now we have what these two are left. So we have Na, that's your metal, Cl, that's your anion. All right, this is going to be an aqueous solution. That's your salt. That's your ionic compound. Okay, so that's one example. Let's look at another one. Let's say if you are mixing HBr, hydrobromic acid with barium hydroxide. Okay, so you're mixing these two together. All right, so here is my acid because that's my H, and then here is my base here. All right, that's my hydroxide. All right, so what's going to happen? Well, as you already could tell, all right, so you have your H and OH, they're going to combine together to make H2O. That's your water, okay? And then lastly, you have your barium and your bromine. All right, bromide. You just always want to make sure that you have the correct formulas. So barium is a +2, bromide is a -1, so you need 2 bromides. All right, and so that's your salt here. And obviously, because it's a chemical reaction, you just only want to make sure that everything is balanced accordingly. And so to make sure everything's balanced accordingly, I believe I will need 2 HBRs and 2 H2Os. All right, to make sure everything is balanced correctly. But yes, so this is another example of an acid-base neutralization reaction.